Welcome dear Mathletes once again to Mathlete Minds. We continue our journey of CBSE Class 10 Mathematics, and right now we are focusing on the topic of similar triangles. Now in the previous video of the same, we had understood the basic proportionality theorem and done some applications pertaining to it. In this particular video, we'll take up the converse of basic proportionality theorem and understand some of its applications. Now, what exactly is the statement of converse of basic proportionality theorem? Now, we know that converse of any theorem is just the reverse of the original statement. So here, if we take any triangle and if we draw any straight line intersecting two sides of the triangle, then if this line is dividing the two sides which it is intersecting proportionately, then it will be parallel to the third side. So here let us take the reference figure ABC, and DE is a straight line which is intersecting AB at the point D and AC at the point E. Now if we get the proportion AD by DB is equal to AE by EC. If we get this proportion, then that means DE has to be parallel to BC. So that is what proportion done, parallel one. So this is the statement of the converse of BPT. Now let us, and here we can take any triangle. It is not mandatory that you have to take a particular type of triangle. It can be equilateral, isosceles, scalene, any type of triangle. And this line can also be drawn parallel to or intersecting any two sides of the triangle. Let's see how we can prove this theorem. The converse of basic proportionality theorem, in order to prove it, we'll be drawing another straight line over here, that is DN, and we'll assume that, okay, if DE is not parallel, let us draw another line that is DN, and DN is parallel to BC. If DN is parallel to BC, then in that case, AD by DB is equal to AN by CN. This is by the original statement of basic proportionality theorem. That is, if a line is drawn parallel any side of a triangle, then it divides the other two sides proportionately. So, but we are already given in this statement that AD by DEB is equal to AE by EC. So if you look at these two proportions, the left hand sides are both equal to AD by DB. So we can equate the right hand side and say AN by CN is equal to AE by CE. So now if we reciprocate this AN by CN and write it as CN by AN, this is equal to CE by AE. Add 1 to both the sides, N by AN plus 1 is equal to CE by AE plus 1. So if we take the LCM, CN plus AN will become AC, AC by AN, and CE plus AE will also become AC by A. So eliminating AC, we get AN is equal to AE. So this means that AN and AE are equal. That means this can only happen that when N and E are the same coinciding points, or DN is completely superimposed on DE. So since DN is parallel, so automatically DE is parallel to BC. DE is parallel to BC. So this is how we prove the statement of the theorem. Now let us move on to some applications of this theorem. So here we have a figure ABC where we get AD is given as 1.4, AB, the whole line is given as 5.6, AC is given as 7.2, and AE is given as 1.8. Now you can do it by two ways. Either you can take the values directly and find out the proportion. So if I take the values directly, AD by AB, and I take the value AE by AC. So AD by AB here 1.4 by 5.6, that is equal to 1 by 4. And AE by EC, this is 1.8 by 7.2, that is also 1 by 4. So they are forming a proportion. Both the ratios are equal, so they are forming a proportion. Hence, we can conclude that DE is parallel to BC. This is one way of doing it. Directly, you can take the values. Otherwise, you can find the value of DB and EC by subtracting. Here we are given AB is 5.6 and AD is 1.4. So dB will be equal to 5.6 minus 1.4, that is 4.2. And similarly, EC can be obtained as 7.2 minus 1.8, that is 5.4. So if you take the ratio AD by dB, this will be 1 by 3, and AE by EC, that will also be equal to 1 by 3. So you look over here, this is 1 by 3, 1 by 3. The ratios are the same. So we can equate these two ratios and make it a proportion. Here, of course, we'll get different values. So you cannot compare this ratio with this ratio because we are taking here the ratio of the full line. Here the ratio is of a part of the line. So don't get confused over here. So you can do it directly this way and say that therefore, since the ratios are the same proportion, so DE is parallel to BC. Either way you can choose. Not necessary to do both the methods. Next question is, in the figure, AD by DB is equal to AE by EC. It's already given. AD by DB is equal to AE by EC. So if we look at this, that means we can apply the converse and immediately state that this implies DE is parallel to BC. And we are also given that angle ADE is equal to angle ACB, this side. Prove that ABC is an isosceles triangle. So if we get DE is parallel to BC, then we can say that angle ADE is equal to angle ABC. Why? Because they are corresponding angles. These two lines are parallel. But we are already given that angle ADE is equal to angle ACB. So from these two relations we get angle ABC is equal to angle ACB. So this means that if the base angles are equal, the sides subtending the equal angles are equal. So we get AC is equal to AB. Therefore, triangle ABC is an isosceles triangle. Moving on to the next question, we have here the side BC of the triangle ABC is bisected at the point D. This is the triangle ABC and this side is bisected at the point D. O is any point in AO, in AD, such BO and CO are produced to meet at AC and AB at the points E and F. AD is produced to X such that D is the midpoint of OX. Prove that AO is to AX is equal to AF is to AB and show that FE is parallel to BC. So two things we have to do over here. So first of all, we'll focus on this part. We are given that D is the midpoint of B. So AO becomes the median of the triangle ABC, one of the medians of the side BC. So again, also it's given that BO has been extended to E. It is the same straight line. And CO has been extended to F. And this O is any point. It is not mentioned that it is the centroid over here. So now, if we take the figure BOCX, another important aspect is this AO has been extended to this point X over here, such that OD is equal to DX. So if we take the figure BOCX, both the pairs of the diagonals of this quadrilateral BOCX are bisecting each other. That means BD is equal to DC is initially given and OD is equal to DX. So BOCX becomes a parallelogram. BOCX becomes a parallelogram. The parallelogram. So that means OC is parallel to BX. And similarly, BO is parallel to CX. So now if we focus on the triangle ABX, in the triangle ABX, because CO has been extended to OF, so OF is also parallel to BX. So if OF is parallel to BX, then from the triangle ABX, I can write here AF by FB is equal to AO by OX. So we get this relation over here. AF by FB is equal to AO by OX. But we have to prove AO by AX. So what we are going to do is take the reciprocal. So FB by AF is equal to OX by AF. This has come from the initial statement of the BPT theorem. So now if we add 1 to both the sides of this proportion, add 1 to both the sides of this proportion, FB plus AF. FB plus AF is AB. So we get AB by AF on the left hand side, OX plus AO. OX plus AO is AX. AX by AO. So reciprocate this again, so we get AF by AB is equal to AO by AX. This is what we had to prove. Now let us move on to prove the second part. So in the second part, if we get back to the first triangle, we have got here AF by FB is equal to AO by OX from the triangle ABX, because OF is parallel to BX. Now this is by the original BPT theorem. Similarly, OE is parallel to CX, so we can write here AE by EC is equal to AO by OX. So now, since the right hand sides are equal, we can equate the left hand sides and say AF by FB is equal to AE by EC. Now from the converse of BPT, if we take the triangle ABC, AF by FB is equal to AE by EC, therefore FE is parallel to BC. So twice we have to apply here BPT, and then we have to apply the converse of BPT. So this of course is a lengthy solution, but you must focus on the initial part first. That is, you have to focus on this quadrilateral over here, prove it to be a parallelogram, and once you prove it to be a parallelogram, the rest of the things will follow. Moving on to the next question. We are given here ABCD is a quadrilateral, PQRS are points of trisection of the sides AB, BC, CD and DA. Prove that PQRS is a parallelogram. So here we are given a quadrilateral ABCD where PQRS are the points of trisection of the parallelogram, of the quadrilateral. So it's already given in the figure that P is situated here. So these points are already marked over here. That means AP is to PB is in the ratio 1:2. Trisection means dividing in 3 equal parts. So AP is to PB will be 1:2. PQ is to QC will be 2:1. CR is to DR will be 1:2, and DS is to AS will be 2:1. So now if we take the triangle, let us start with the triangle DAC. From the triangle DAC, if I take the ratio of DS by AS, I'll get this as 2/1. And if I take the ratio of DR by CR, I'll get this as 2:1. So because these two ratios are equal, they form a proportion. So I can write DS by AS is equal to DR by CR. So this is 2:1. That means I can now conclude that RS is parallel to AC. Now we take the triangle BCA. From the triangle BCA, we'll get here BP by AP is equal to 2:1, and BQ is to CQ, that is also 2:1. So that means BP by AP and is equal to BQ by CQ, and they form a proportion. So that means PQ is parallel to AC. So we are getting RS parallel to AC, and we are also getting PQ parallel to AC. So this, from here we can conclude that PQ is parallel to RS. Now to prove the other two pair of sides parallel, let us draw this diagonal, that is BD. Now we'll take the triangle CBD. From the triangle CBD, we get the ratio CR by DR as 1:2, and CQ by BQ also has 1:2. So that means the ratios are equal, they form a proportion. So QR is parallel to BB. QR is parallel to BB. So this is one relation. Similarly, we can prove that PS is parallel to DB. So from both these relations, we come to the conclusion that PS is parallel to QR. Now earlier we have proved that SR is parallel to PQ. Now we have proved that QR is parallel to PS. So we are already getting SR is parallel to PQ, So we notice that in this quadrilateral PQRS, both the pairs of opposite sides are parallel to each other. If both the pairs of opposite sides are parallel to each other, then by the very property of the parallelogram, we can come to the conclusion that PQRS is a parallelogram. So with this, we come to the culmination of this video. Hope you liked the explanation. Kindly like, share and subscribe to the channel. Thank you.